Hello everyone, this is the continuation of exploratory data analysis part 2, and in this session we'll mainly focus about the null imputation by univariant approach and multivariant approach. So what is univariant approach? Univariant approach is basically an approach where we use either mean imputation or median imputation or by any constant or by most frequently value to impute that. But important thing is we are imputing only by that dimension. So if you have a data like this, I just created subsample data, and if you are doing a univariant approach, that means you will replace this value by the mean of these values or median of these values or some constant value or the most frequent value. Same approach for the salary. And a lot of times we follow this technique, and intention is to show that these techniques are working fine in a lot of machine learnings, but there is another way which is univariant multivariant approach, and multivariant approach is where you are considering all these features and then you are imputing it. So that's the main purpose. So let's start actually. So I think at least you got some idea like what is univariant approach and what is the multivariant approach. High level, this is our data looks like, and just by seeing the data you can see that we have three columns: age, experience, and salary. Now as age is increasing, obviously the person's experience will also increase and salary is also increasing. In general, this is the relation with these features. Okay, so if you think just from a very basic point of view, that's mean that this should be replaced by something less than 3 years of experience, and salary here should be something between 50 to 110 if you really consider a perfect scenario. Okay, now let's consider if we follow a, mean approach. Now again, I am using the simple imputer for this work. There are many different techniques to do the mean imputation, but this is a from sklearn, and a lot of reference we'll get in this page actually. So if you do this, sorry, I think I need to run this to create the data, and let's run it one more time. Yes. Okay, cool. So it is getting imputed by the mean value, and you see that it's getting imputed, but just if you see from the data perspective, it doesn't look very correct actually, because the experience is 7 and it is 194. So you can understand this mean imputation a lot of times not giving the correct answer. Also, if we have an outlier, it's a very big problem. So normally, before you do the mean imputation, please verify if there is any outlier. It's very important. If there is an outlier, remove the outliers, then apply mean imputations, or do not apply mean imputation, rather go with the median imputation. Okay. Now when coming to the median imputation, one more time let me create the data just to be safe. So when you are doing the median imputation, again very simple approach. Median imputation is giving me 7 and 140. Again comparatively better because the mean was giving me 194, which was very high, but at least median is giving me 140. In this case, median is not really changing the experience, okay, because that's the median value for this particular feature. So this is two very common approach we follow, but again we are not really getting the correct answer actually, right? Because we are expecting something less than 3 and between 50 to 110. So Few other interesting thing on this package is this is I personally used in my projects, that is the indicator flag when I'm doing this kind of null imputation. So for example, one more time, let me show it. So I'm doing again the median imputations in this case on salary feature, and look, still running. Okay, it's got imputed by 140. An interesting thing is I can bring actually a salary imputed indicator, so that just by seeing, like after imputations, when we'll pass this data to the data scientist people or any other consumers, they can easily understand, okay, this value is actually the imputed value. It's not the real value which was available in the data. So this flag is very, very helpful. This kind of flag. Whenever you do any kind of imputation, add a flag with the data, which is very helpful for future analysis. Again, there are a couple of different approach. One is just by a constant value. So for example, you think, okay, 130 is probably the right value for this case, or maybe in this case I can think about 100 is the right value. So let's make it 100 or something. Okay, and then just run this. Again, this value will be imputed by 130, and there will be a flag which will tell us that, okay, this value got imputed, and the imputed flag. So these are the very good technique in data science projects to handle the imputations on a univariant approach with a mean, median, constant value, all this case. Okay. Now coming to the iterative imputer approach, or maybe the multi value imputation approach. So as again I was telling, like, okay, the age, experience, and salary has a very good correlation. Like age and experience are very much correlated, right? And then age and salary is also very much correlated. That's mean whatever we thought that those values should be something like that, but this should be reflected by something less than 3, and this should be something between 50 to 110. Okay, so that's where this iterative imputer is coming very handy. And this iterative imputer, if you just use the default iterative imputer, you can give the max iteration number and random state, so that every time it can generate the same number. And if you run this, let's see if I run it. So then look, my values are coming very, very accurate, because my experience is coming exactly 1, my salary is coming as 70. So this is very good actually. This is exactly what I was looking for. So this is the benefit of using this iterative imputer, and this is the benefit of using this multivariant approach, multivariant imputation approach, because in this case you are not exactly relying on one particular feature, rather you are relying on all these features. And how it works under the hood, what it is doing, it's basically considering this salary as a target variable and age and experience as your features, and trying to impute this. Now after that, it's considering salary and age is your X features and experience as your target feature, and then just running algorithm and imputing it. Now by default, it is using some default algorithms, but there is an option also that you can pass your own algorithms, whatever you want. Like in this case, I thought, okay, I will do linear regression on this data, because I know just by seeing this data, they are linearly correlated, right? There is a linear relationship between age and experience, and you can go by that actually, the imputation approach. So if I do that, a lot of time, if it's might not work properly, because if you do this linear regression approach, um, then look, this value is coming as a negative, which is probably not right. Okay, so this is some of the things you need to consider when you are doing this thing. Again, there is another week 3 we can do, that is K-NN imputer, and if you do this thing, then again K-NN imputer is giving you these values. So the main intention is, if you use this default way of handling the imputation technique using this linear model and iterative imputer, then we're getting the very correct number for the imputation. So that's why I normally prefer this univariant approach to impute the values instead of multivariant approach instead of a univariant approach. And this gives me a lot better in the real life also. So if you know the relation between some of these features, like okay, like in this case I know age and experience is probably very much correlated. Actually, age and salary is correlated. So then in that case I'll say probably just write a simple linear regression and populate these values. So that way you will get a better picture instead of just imputing by null or imputing by mean or median or something like that. That's the main intention to show in these presentations. Okay, I hope you like it. If there is any question, I'll provide my email ID. You can email me. We can learn together. Just if you like it, please give a thumbs up or subscribe my channel. I'm trying to grow slowly. Thank you. Have a nice day. Bye.